Okay, I would like you to watch this video and then do page 195 in your book, and you should try to do most of the problems. One of them I just want you to skip. It's kind of a hard one and it takes a long time to figure out, but you can skip number 5. But what I'd like you to do is try to do the rest of the worksheet. Okay, now what I'm going to do is I'm going to do problems 1 through 4 for you. So I want you to see how this is done. So you can kind of look at the instructions on the worksheet. So the first thing that you have to do is you have to assign oxidation numbers. Okay, so hydrogen's always +1 unless it's with a metal. Okay, that makes the nitrogen -3. Anything by itself is 0. Okay, oxygen's always -2 unless it's a peroxide. That makes this nitrogen +2. Oxygen is -2. Hydrogen is +1. Okay, so now what we're going to do is we're going to write the oxidation and reduction half reactions. I myself like to do the reduction one first. It's just easier for me to think about in my brain. So I look for changes in oxidation number. So I see that oxygen's oxidation number went down. So you can see that the oxygen has been reduced. So here's the reduction half reaction. I'm going to write it just like it is in the equation. O2 with the 0 up here. Alright, and then I'm going to add electrons to the more positive side, so I'm going to leave a space. Then I'm going to go oxygen -2 over here, but I have to balance my equation. So there's a 2 here, so I got to use a coefficient to balance it like that. Now, anyway, I notice on this side 2 times a -2 is -4, and 2 times 0 is 0. So I have to add 4 electrons to this side. And anyway, so I get O2, 0 plus 4 electrons gives me a -4. So the total charges on this side have to equal the total charges on this side. So 2 times the -2 is -4, -4. Okay, the oxygen is being reduced. Okay, its oxidation number is going down. Okay, now, so anyway, it gained electrons. Gaining electrons, remember, I don't know if you watched another video, but Leo the lion goes grr. Gaining electrons is a reduction. Gaining electrons reduction. Okay, now, the other thing, we're going to look for something else that changes, and so you can see the nitrogen, it changes from -3 to +2. Okay, so I'm going to write it just like I have here, nitrogen -3. Okay, now the electrons always are added to the more positive side. So I put nitrogen +2 here. Alright, now I balance it. Well, there's one nitrogen here and one here, so I don't have to worry about putting any coefficients there. But now now I have to balance the electrons. So I got to think, what number plus a -2 would equal -3? And your answer would be 5 negative, because 5 negative charges plus 2 positive charges gives you a net of 3 minus charges. Alright? So you can think, sometimes I like to tell students, think like on a number line. This kind of helps you. So if you have 0 here, then you got -1, -2, -3. Here's -3 here. And then over here you got +1, +2 here. Okay, what's the difference between -3 and +2? The answer is 5. Okay, so anyway, that's the oxidation half reaction. Whenever the oxidation number goes up, okay, that's oxidation. That's losing electrons is oxidation. All right? Now, what we're going to do is we're going to balance the half reactions. The rule is the electrons lost must be equal to the electrons gained. So oxygen loses 5, okay, but then the oxygen gains 4. So what we got to do is we got to balance this whole reaction by putting whatever number would be equal to what one loses, one gains. And so both, you can see 5 and 4 both go into 20, so you would put a 5 here and a 4 there, because 5 times 4 is 20 and 4 times 5 is 20. That's the lowest number that both go into. Now what you can do then is you can use these half reactions to help you balance the equation up above. Like there's 4 nitrogens here, there has to be 4 over here. There's 5 O2s here. Okay, now the thing is, that gives you those three coefficients, but it doesn't give you the one over here. Okay, so basically what you have is you have 10 oxygens total over here, and you got 4 here, so you need 6 more. All right, so what you would do is you could put a 6 here, or you could say, well, 4 times 3 is 12 hydrogens, 6 times 2 is 12. All right, so that ended up balancing that equation. Okay, let's look at another one here. Okay, so step 1, assign oxidation numbers. Oxygen -2, copper's +2. Hydrogen's always +1 unless it's with the metal. That makes this nitrogen -3. This nitrogen 0. That's +1. That's -2. Copper 0. Okay, I see copper goes from +2 to 0. That's going to be the reduction. See, copper is +2. It goes to 0. Its oxidation number is going down. It's being reduced. All right. Now the electrons are always added to the more positive side. Okay, make sure they're balanced. Well, 1 and 1, they're balanced. So you got to add 2 electrons to the copper. Okay, then we're going to look for what else. Okay, so if I'm looking through here, I see that nitrogen is -3, but then it's 0 over here. So the oxidation half reaction is nitrogen. It's -3 over here. Okay, and then it's 0 over here. So I know that the nitrogen's oxidation number is going up, so it's being oxidized. Now, before we figure out the electrons, we got to balance the equation. So there's 2 nitrogens here, so we're going to need a 2 here. And then 2 times the -3 is -6. So what number plus 0 is -6? That's going to be 6 electrons there. Okay, so you want to make sure that both sides of your half reaction have the same number of electrons. So 6 here, 6 here. All right. Now, the next thing that we're going to do is we're going to balance electrons. 2 times the -6 makes a total of -12 electrons here. We need to have -12 here. So we're going to have to multiply this whole equation by a factor of 6. All right, that's balancing the half reaction. Okay, so then we'll go ahead and try to balance our equation here. Okay, just make sure you know what I did there. 6 times the -2 is 12 electrons here, and then there's, let's see here. Oh, wait a minute here. I didn't do that right, because here's what I did. There's 12, but there's only 6 here. I don't need a 6 there. I need a 3 here, because 3 times the -2 is -6. Okay, my mistake there. Okay, because you got 6 electrons here. The electrons lost, losing electrons is oxidation, must be equal to those gained. So this one's losing 6, this one has to gain 6. All right, so there would be a 3 in front of that. So then you try to balance the equation. So you put a 3 there. Okay, and then you're going to need a 3 over here. You're going to need a 2 in front of this nitrogen right here. This one already has 2, so let's see, we got to balance the waters. Okay, so it looks like we got 2 times 3 is 6 hydrogens here. So if we put a 3 there, that should balance everything out. Okay, that one's good. Let's try another one. Okay, why don't you try to pause the video and assign oxidation numbers and then come back and see if you do it right. All right, oxygen's -2, always, unless it's with the metal, or unless it's, no, oxygen's always -2 unless it's with the peroxide. That makes the lead +4. Okay, iodide is always -1. Oops, there we go. Let's see, back to my pen. Okay, iodine is -1. That makes hydrogen +1. Okay, this iodide is -1, but there's 2 of them. That makes this lead +2. This iodine is by itself. This is so it's 0. This is -2. This is +1. Okay, so let's look for changes. Hey, I see lead. It's +4 over here. Its oxidation number is going from +4 to +2. So I'm always going to add electrons to the more positive side, so I'm going to leave a space there. All right, make sure the leads are balanced, so I'm going to have to add 2 electrons, because +4 to get it to +2. Okay, now the iodide is the other, and this would be the reduction half reaction because the oxidation number is going down. Okay, now let's go over to the iodide thing, and so here we have I -1, here. Now, the tricky part of this one maybe is, well, there is an iodide here, but it's the same charge, so you don't want to pick that one for this one. Okay? And so we're going to pick the one that is different, which is I2, 0. We have to balance our equation first, and then we're going to add 2 electrons to this side here, because the electrons lost, this is the oxidation. Remember, Leo, losing electrons is oxidation. Leo goes grrr, gaining electrons is reduction. All right, so that's how you can remember which one means losing, which one's gaining. But anyway, so the electrons lost must be equal to the electrons gained. All right, now we can go in and we can try to balance our equation. There's 2 iodides there, so we'll put a 2 there. All right, and then that's good. Okay, now what we'll do is we'll just check everything. So 2 hydrogens, 2 hydrogens. Oh, this one looks like it has a little bit of a problem. Let's see here. Because we have 2 oxygens over here, and we only got 1 over here, so we're going to have to put a 2 there. That makes me have 4 hydrogens. So what I'm going to have to do is put, instead of having a 2 there, I'm going to have to change that to having a 4, make sure I have 4 there. So need to erase that and then put a 4 there. Sometimes when things are in like 2 different places, you have to manipulate what you get here. It doesn't always balance the equation exactly for you. All right, everything else should be balanced. 4 iodides, 4 iodides, 2 oxygens, 2 oxygens, 4 hydrogens, 4 hydrogens, 1 lead. Okay, that's good. Let's try one more. Okay, this one, why don't you try it yourself and then come back and watch me do it. So pause the video, try it yourself. Okay, so silver is always +1, oxygen is always -2, unless it's a peroxide, which this is not. And so then you can take like sulfate, which we know that sulfate altogether is -2, and oxygen is always -2 for -8. Okay, it's supposed to be a 2 there. That makes the sulfur has to be a +6. Okay, hydrogen is always going to be +1. That's going to make this -3. Okay, unless hydrogen's with a metal. This is -2. This is +1. Okay, silver is by itself 0. This oxygen's -2. That's a total of -6. So this must be +3. Okay, hydrogen's always +1. Anytime you have a sulfate, it's always -2 +6. Good thing to memorize. It makes things go a lot faster. All right, so I see silver's going down. It's being reduced. So I'm going to start with silver. Silver will be reduced. So I go Ag2 +1. Okay, that's the more positive side. Leave space for electrons. Ag0. I have to put a 2 in front of that. So what number do I need to, what electrons do I need to add? Well, it's going to be 2 electrons here, because 2 times a +1 is 2, so I'm going to need to add 2. Okay, then I look through and I see that this arsenic thing here, this As, it's -3 here, and over here on the other side, it's +3. So I go As, and I bring the subscript with it, As, and it's +3 over here. Okay, so we have to balance the equation first, so there's 2 there and there's 1 there, so I'm going to put a 2 here. So 2 times 3 is -6, and this is 2 times 3 is +6, so the difference there is 12 electrons. All right, now the electrons lost must be equal to the electrons gained. Okay, so this is losing electrons, oxidation. I forgot to write that this is the oxidation, and this is a reduction. You can't have a reduction, okay, without having an oxidation, because reduction is gaining. You can't gain without something losing. All right, anyway, 12 electrons here. We only got 2 here. So we're going to have to multiply this whole equation up here by a factor of 6. Okay, so 6 times 2 is 12. There's 12 electrons there, and there's 12 down here. Now I'm going to attempt to balance the equation. So I'm going to put a 6 here. That's what my half reaction says. And then 6 times 2 is 12. I'm going to put a 12 over here. Okay, this says I need 2 of those right there. and it's already 2 over there. Now, here's the thing. I have 6 SO4s here, so I'm going to need 6 SO4s over here. So I'm going to put a 6 there. There's supposed to be a plus sign there. Okay? So 6 SO4s there. Now, let's see here. So we got the oxygens there, so we can do these oxygens, or we could do the hydrogens, because there's 6 times 2 is 12 hydrogens here. And there's already 6 here, so we need 6 more, so I'm going to put a 3 there. Now, there's the oxygens are taken care of there, so 3 oxygens. Yep, that would do it. Okay, so that would balance your equation. Okay, that's it for this video. What I want you to do now, if you remember, you can go back to the worksheet. You can skip problem number 5. Okay, so skip problem number 5, but then see if you can do the rest of these. So make sure you have a pretty good idea how to write some of these. Okay, that's it for this video then.